This video focuses on processing the signal data from the sidescan sonar and creating the final mosaic. First thing we wish to do is load the project and make sure that our view is set to drawing mode, sidescan, high resolution. Initially, you can see the sidescan mosaic actually looks pretty good from the start. However, some of our nadir tracks and issues are creating some artifacts. One way to eliminate that is to select this line, set the transparency for nadir on the selected file. You can play with this anywhere from 0 meters to the entire line. We set it for around 25 meters in this case. I think that'll work. Eliminating that dark line. Yeah, so you can see here is the last remnants of the dark line from nadir, and then there's a gap right here. I can isolate this to show you what's been done. So we basically said around nadir, get rid of 25 meters. That looks like it should be good for the project in general. So we'll go ahead, select that line, right-click, on our file manager, highlight the line that we set the nadir transparency for, say make like selected, transparency, and then we will check all to say please modify all these lines to make them look like this highlighted line, where we set the transparency to 25 meters. We'll close that. And now you can see that all the lines, you can isolate any random one of them, has the center part of nadir taken out from it. Turning all the lines back on display, except for the cross lines. You can now see a rough mosaic of what we expect to see from sonar data. You'd also have the possibility of changing how the lines overlap. If you go to under view, side scan mode, you have the option of doing cover up, which is our current one, shine through, which takes the highest value, maximum value, and displays that all the way through. You can also do average, where it's averaging the two different sets of side scan data. Or one I find very useful is the RMS, root mean square, which you can imagine that just looks at the overlapping data and takes the root mean square of it. I like that one pretty much right there. You get to see a lot of the features, some of the different acoustic returns from the sediment or whatever the bottom is, as well as the main geologic feature and some rock outcrops or something right around in here. It is also possible to adjust your gain settings. There's a lot of different settings for gain. In this case, we'll simply look at one file. I'll actually probably choose one that's a little bit further north so we have some features to see. There we go. We can go in this case to settings, select that line, right click, settings. We have a lot of different gain features. We can turn on beam angle correction. Apply that, see what it looks like. It kind of washes things out a good bit, so I don't like that one as much. Go back to our original. Maybe we could try angle gain correction. Or we could try CDG instead. No, it doesn't really look like it's helping that much. If you wish to do the EGN, empirical gain table, you have to build the entire empirical gain normalization table. You can choose one or two lines or the entire set of lines. Once you've determined the gain settings that you wish to use on a particular line, you can go ahead and start to export the mosaic. You have to make sure that your project mosaic has all the lines enabled. Anything that is not displayed on the screen will not be exported as part of the project mosaic. You also want to make sure you don't have the cross lines or other lines you don't wish to have in the project mosaic. Once we have the mosaic looking as we wish it to, we'll zoom in so we don't have too much blank black space. We'll go to post-processing, export, save project as GeoImage. We'll let it save to the default location, in this case under the processing folder with the dive we've decided under a folder called GeoTIFF. We wish it to be a GeoTIFF, so there are many different options. 8-bit is good. We want the background to be transparent. You can leave this where it builds only the tiles or the whole mosaic. You can exclude tiles with no sonar data. You can do crop image. You can do many different options. It's up to you. Typically, you want to have a good resolution, so I would say we'll go for a resolution of about 1/4 meter per pixel. And we do not want grid lines on it. We want just the image, so we'll turn that to 0. This will tell you the size. 6 megabytes is pretty good. You can actually probably go to 0.2 meters for 0.2 meters per pixel, and we'll hit OK. Now that the mosaic is done building, we can go to our Explorer, browse to the folder where it saved it, Sentry 386, go to GeoTIFF, go to, looks like it's a 19 megabyte file, very reasonable. Open that up. And we now have a mosaic in a GeoTIFF format, and everything looks good. Another option that we can do is export the individual lines. If you're going to do that, you need to turn the nadir transparency off. We need to isolate a single line. So now we'll just go ahead to individual line, transparency, clear transparency on all files. That seems to have worked there. So all the files are now cleared of their transparency. We'll turn them on. Turn the cross lines on as well. Now go again to export, individual geo images. You want a GeoTIFF, 0.2 meters per pixel. Background will be black again. Make it transparent like the others. Again, get rid of your grid lines unless you do want them. And then hit OK. And it will start creating individual GeoTIFFs for each individual line, which you can see going to Internet Explorer, which you can see are being created as GeoTIFFs on an individual line-by-line basis. This concludes this video segment explaining sidescan processing, mosaic production, and GeoTIFFs for individual lines. Thank you very much.